What exactly is a black hole? Its name may contain the word hole, but it is not a hole, and it is not empty. So what is it, really? Many people worry that black holes constantly devour matter, and wonder whether they could eventually destroy the entire universe. But the question people care about most is this: where is the black hole closest to Earth? The explanation given by scientists may completely surprise you. In fact, no matter how large a black hole is, it is still just a single celestial object in the universe. It cannot even swallow a galaxy made up of hundreds of billions of stars. So how could it possibly destroy the entire universe? Let's take black holes near our solar system as an example. At present, the closest known black hole to us is Gaia BH1. In 2022, scientists discovered its existence through observations from the Gaia spacecraft. It is a stellar mass black hole, located only 1,560 light-years away. Converted into distance, that's roughly 150 million kilometers. If we go by Voyager 1 speed of 17 kilometers per second, it would take about 28 million years to get there. This distance is still extremely safe for Earth. There is absolutely no chance we could fall into it. So why do some people still worry that black holes will keep swallowing surrounding matter, or that there might be a black hole lurking near the solar system? That's because our intuition about the universe is often wrong. A black hole is essentially a bottomless abyss. It is an invisible sphere of ultra-dense matter, and also a region of space. Within this region, nothing can escape, not even light. It is a one-way road into the unknown. Anything that enters it disappears forever. In our observable universe, if black holes truly never released anything, that would mean they would slowly grow larger and larger. But reality is not that simple. Black holes don't just consume matter, they also release energy, what we know as Hawking radiation. If we assume black holes can exist forever, then over an eternal time scale, they would absorb more and more matter, more and more light, and even more and more energy. This process would have no limit and no end, given infinite time. So the question becomes, over an eternal time scale, could black holes eventually absorb all energy and all matter in the universe, until nothing is left? That is why we must understand the true nature of black holes. Are they really the terrifying monsters of science fiction that can swallow entire spaceships? Are they objects that challenge our understanding of space, time, and matter itself? To answer that, we first need to be clear about what a black hole actually is. First of all, a black hole is not a hole, nor is it an object with a surface you can stand on. The simplest definition is this: it is a region where gravity is so strong that nothing can escape from within it. Once an object crosses this boundary, it is torn apart and disintegrated, never able to return. This boundary is what scientists call the event horizon. If you approach a black hole, before reaching the event horizon, you could still turn around and accelerate away, but once you cross it, you are doomed to be pulled toward the center. No matter what you do, it is useless. Even if you could travel at nearly the speed of light, you still could not escape. That is what makes black holes so terrifying. So, we should not think of black holes as cosmic vacuum cleaners. They do not suck things in like a vacuum. They consume everything, purely through gravity. If, through some absurd magical trick, we replaced our sun with a black hole of the same mass and size, Earth would continue to orbit exactly as it does now. The only difference is that we would live in a world without sunlight. The result would be inevitable. We would freeze to death, because there would be no light and no heat. But from a gravitational standpoint, we would not be pulled in. That's because Earth is 150 million kilometers from the Sun, and does not lie within the gravitational range of a stellar mass black hole. Mercury, however, would be a different story. At present, scientists know of two main types of black holes. One type is stellar mass black holes, with masses ranging from several to several dozen times that of the Sun, formed from the collapse of massive stars after they die. The other type is supermassive black holes, with masses millions to billions of times that of the Sun. They reside at the centers of galaxies. You might think smaller black holes are more dangerous, but in reality, the larger the black hole, the lower the average density at its event horizon. This completely defies intuition. For example, the supermassive black hole at the center of our Milky Way, Sagittarius A*, has a mass about 4 million times that of the Sun. The average density at its event horizon is actually lower than that of water. If you could take 1 cubic meter of space from its event horizon, it would weigh less than 1 ton. Stellar mass black holes, on the other hand, have densities so extreme, they are trillions of times denser than lead. So how do black holes form? For stellar mass black holes, they almost always come from the death of a massive star, typically one with more than 20 to 30 times the mass of the Sun. At the end of its life, the star explodes as a supernova, leaving behind a stellar mass black hole. The origin of supermassive black holes, however, remains one of the greatest mysteries in modern astrophysics. They are simply too massive to have formed from the collapse of a single star. Scientists have proposed several possible explanations. First, they may have formed in the early universe, just a few million years after the Big Bang, through the merger of thousands of smaller black holes. Second, they might have formed from the direct collapse of enormous gas clouds, without ever passing through a stellar phase. There are also theories suggesting they are relics of the Big Bang itself, so-called primordial black holes, formed from density fluctuations in the early universe. Once formed, black holes grow by consuming gas, dust, and stars, and by merging with other black holes. When two galaxies collide, the supermassive black holes at their centers can orbit each other for millions of years, eventually merging into an even larger black hole. This process releases powerful gravitational waves and X-rays. With advanced astronomical telescopes, we can detect their presence, especially through the high-speed jets of particles ejected from regions near black holes. These jets travel at nearly the speed of light, and can extend for hundreds of thousands of light-years, far beyond their host galaxies. They carry enormous energy, heating interstellar gas, suppressing the formation of new stars, and inflating gigantic bubbles in the cosmic void. So, can black holes destroy the universe? The answer is no, at least not in the way we usually imagine. Over the next tens of trillions of years, black holes will remain local phenomena. They are powerful, but their influence is limited to the regions near galaxies. They cannot drain the entire universe. But what about over an eternal timescale? In a future so distant it is beyond comprehension, the fate of black holes may become intertwined with the fate of the universe itself. What the ultimate outcome will be, humanity may never know.